Hello, everyone. I'm Ahmed Zaalouk, PhD candidate at Concordia University. Today, I'm presenting our paper, Simulation-Based Integrated Transportation Planning in Panelized Construction, co-authored with Dr. Sadiq, Altaf, and Dr. SangHyeok. So let me switch the gear a bit from previous presentation to the offsite construction. So actual panelized construction, it's an offsite construction method that produces building components in a factory-controlled environment, then transport these components to the site for building assembly. The process starts by the panelization. So buildings are transformed to a set of panels. These panels then produced in several production lines factory, either using semi-automated or automated ways. Then it's being transported to the site. We can see that after the production, we have the loading stage. Then we transport using two actually parts of the transportation fleets. We have the trailers, which carry the panels. Then we have the trucks that tow these trailers to the sites. Upon delivery to the sites, actually we have here two different tasks. So the trailers stays on the sites to be unloaded by using the cranes, and the trucks are leaving to start another task in the supply chain. Once all the panels are completed, all the resources are released, and the same procedure starts for another building. So in fact, this approach compared to other offsite construction methods like volumetric model has a lot of advantages like flexibility in the schedule, customization, cost-effective transportation on the site because of the lightweight of the panels compared to the volumetric modules. However, it has also several challenges in terms of supply chain management, because managing the flows of individual panels in the supply chain, distributing them to the different sites is more complicated than managing the flow of complete volumetric modules. Also, we have logistics issues. Sometimes we experience bottlenecks in the supply chain and coordination issues as well between the factory production and the demand for the sites. So as we see from the video I presented, the transportation can be the bridge between what's happening in the factory and what should be delivered on the site. That's why here we propose integrated transportation planning. We're trying to systematically propose a method that regulate the procedures between the factory production and the on-site assembly. So current work in transportation planning and offsite construction has some limitations and the gaps. So actually, the most of the work now, they're just considering the distribution flow from the factory to the site, but they don't consider how these distributed trailers and the trucks will be returned back to the factory to complete the loop of the production. Also, there is no transportation planning integrating the three phases together, like production, transportation, and on-site. I'm talking about here panelized construction procedures. Also, most of the times in the transportation planning for simplicity, trucks and trailers are considered as a single unit, and there is no comprehensive just-in-time strategy to manage the supply chain. So most of the time, the factory keep producing the panel using the push approach. Somehow they can coordinate between the requirements of the site, but a comprehensive strategy to manage the production according to the site needs still is not realized. So our objective here, we're trying to propose integrated transportation planning for the pre-production planning phase. We need to coordinate between the transportation, what's happening in the factory, and what's required on the site to avoid delays and achieve just-in-time supply chain management. So the proposed framework, we proposed three main steps. First of all, we defined the operational objectives and the constraints for the supply chain management. We had a lot of meetings with panelized construction companies, and also we had collaborative research with many companies in Canada. Then we developed, this is actually the core contribution here, we developed a transportation planning algorithm to standardize and regulate the procedures for the transportation, considering the production and also on-site assembly. The developed algorithm works as embedded logic for I developed simulation model for the supply chain. So here we actually represent the entire supply chain constraints and all supply chain entities as agents. They interact with each other using the logic we developed in the algorithm to achieve integrated scheduling for the supply chain. And finally, we validated our work using actual case study and actual data collected for one of our partners. So the developed algorithm actually here, we try to divide the transportation to two different flows. The flow from the factory to the site, which actually we call it the dispatching flow when we need to dispatch the panels to the site. And also we have another flow, we call it reverse flow when we need to return the empty trailers from the site to the factory. The point here for the return flow, that if we don't return the trailers on time, actually we experience bottlenecks in the factory because the factory keep producing the panels and these panels should be loaded to empty the production lines for the next production task. So the first part here for the dispatching flow, we coordinate with the production envelope. So the first part here, we keep monitoring the progression of the production line. And once the panel is produced and loaded, it should be scheduled for dispatching. However, here we should consider two things. We should consider the availability of the cranes on the site. So when this panel delivered to the site, it should be immediately unloaded. So that's why here we propose a selection procedures to check the readiness for the site to deliver the panels, and also we need to check which panel should be delivered according to the assembly sequence. So because the site actually assembling the panel in specific sequence, for example, ground floor, first floor, and roof. So we need first to deliver the panels according to this sequence to avoid the delays and expedite the progression on the site. The second part of the algorithm, actually, we're trying to return the empty trailers from the sites, considering the coordination with the on-site assembly process. So once the panels are unloaded and the trailer is empty, we schedule this trailer for return, considering actually the empty trucks in the supply chain. That's why these trailers can be returned in the factory and we keep continuing the production and the entire supply chain keep producing the panels without experience bottlenecks. Here is actually how the simulation model is structured. We have different agents, each agent representing a supply chain entity. For example, we have the factory, we have the trailer, the trucks, and we have the project sites. These agents communicate with each other using the embedded logic for the algorithm. So for example, production orders are sent to the factory, then the produced panels are loaded to the trailers, trucks are assigned to take these trailers to the site. Meanwhile, cranes and the crew delivered on the same time to ensure that there is no delays for the on-site, and the project sites keep monitoring the progression of the on-site assembly, as I mentioned, until the entire required projects are completed. So this is how the supply chain integration is achieved. So we can see now here the green blocks are the size, the red block is the factory, and this is an example for the dispatching. So we can see a trailer going with the truck for the dispatching. Then once trailers are dispatched, trucks leaving the trailers and going back to the factory for another task. Meanwhile, the on-site assembly is ongoing, and you can see that all the operations of supply chain are coordinated so concurrently we can finish many projects at the same time. So we had a case study with Aquabuilt. It's a home manufacturer based in Alberta, Canada. So we have here supply chain in this month. It's April 2021. We need to deliver and to produce 35 homes. We have 5 production lines in the factory, and we're using 2 types of trailers depending on the type of the panels required to be delivered. So we did a lot of verification and validation steps to compare the actual results here with the actual schedule of the factory. And actually we achieved a lot of savings in terms of time and in terms of required number of resources. So for example, in this schedule, we used 6 trucks. We achieved only the same schedule using 4 trucks. So in conclusion, we're proposing a synchronized transportation planning framework to link the factory and on-site assembly in the panelized construction. We propose an algorithm that regulates the flows in the supply chain, considering two types of flows, dispatching and reverse schedule, and we can achieve here operational data-driven decision-making for the supply chain management. Future work, actually, we need to integrate the proposed method with real-time data, looking for developing a digital twin, and also we think to extend it by different type of transportation, like including ships and rails, and finally, we might include some sustainability metrics to evaluate the performance of the supply chain. Thank you so much.